Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Hakim bin Rizal. So today I will present on the group assignment entitled Impulse Generator. So our group consists of 5 people including myself, Adam, Afiq Ridwan, Amir Shazwan and Farid Irfan. So as for introduction, impulse generators produce brief but powerful voltage or current surges. These devices are impulse voltage and current generators. Power equipment is tested for lightning and switching surge resistant at high impulse voltages. Nuclear physics experiments also use high amplitude front impulse voltages. Lightning arresters, fuses, lasers, thermonuclear fusion, and plasma devices require high amplitude electrical currents for testing. So key features and components of an impulse generator, there are 4 of them. The first one is rise time, refers to the duration required for a pulse to change from a low amplitude to a high amplitude. The second one is fall time, the duration required for the pulse to shift from a state of high amplitude to a state of low amplitude. The third one is pulse width, the period of time during which the pulse maintains its highest amplitude. And the last one is amplitude, it refers to the highest level of voltage and current reached by a pulse. There are 2 types of generators. The first one is impulse voltage generators and the second one is impulse current generators. So as for applications, the first one is electrical testing. Impulse generators test electrical components, cables and insulation system under high voltage or high current conditions. Second one is for calibration. They calibrate instruments and measurement devices. The third one is research and development. Impulse generator lab researchers examine electrical system behavior under transitory situations. So benefits of using impulse generator, it can alterable rate of recurrence and percentage of time between rest. Second one is able to provide very capacitive windings and status. And the last one is the waveform at the output is fully modulable. So that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq bin Ridwan. Today I will present about for my part that is methodology of ORCAD. So for this part, we will start with the construct the circuit in the PSpice. So in the circuit we have a VDC that is we will search a Vsource, and also we have two switch that is normally closed and normally open switch. That for this first one we have two type, that is design cage and MISC. We will select the MISC one type. So for the capacitor we will search for the C analog, and resistor we will search for R analog. So after we done with the circuit, we will put the voltage probe at the end of the circuit at C2 for the capacitor load. So for the second one, we will set the run of time that is 200 microsecond. So after we set the time run of time, we will click the run. So after we click run, we will wait for a few minutes and a few seconds, and then the graph will show up. So when the graph will show up, we will take 4 points at the graph. So that 4 point is, for the first one is a V peak, that is peak value of the simulation graph that we get. So the second one is V1. V1 is 10% from V peak. For the next one is V2, 90% from V peak. So for the V3 is 50% from V peak. So after we get V1, V2 and V3, we also will obtain the T1, T2 and T3 in the result. So with the result T1, T2 and T3, we can calculate the value of wavefront time, that is TF, with the formula 1.25 multiplied by T1 minus T2 minus by T1. And for the second one, we can get the wave tail time TT with the formula T3 minus by T0. So the T0 is 0 value. So that's all from me. Thank you.
So Assalamualaikum warahmatullahi wabarakatuh. My name is Farid bin Rizal. So today I want to present about the calculation and simulation. So first we need to find the R1, and for the formula for the R1 is TF times by C1 plus C2 over C1 times by C times C2 times 1 over 3. We got the answer for the R1 403 ohms. And for the TT, we got the formula 0.7 times by R1 plus R2 times C1 plus C2. So we got the answer for the R2 is 41 ohm. We move to the V out. So V out, the formula is V in over R2 times by C2 times by beta minus alpha times by exponent negative alpha t minus exponent beta t. So we don't have any alpha and beta answer, so we need to find the alpha and beta first. For the alpha formula is 1 over R1 times by C2. We got the answer for the alpha is 2.48 mega, and for the beta formula is 1 over R2 times C1. We got the answer is 152.44 kilo. So we got the answer for the V out is 100.016 kilovolt. So we move to for the T1, T2, T3. So T1, T2, T3, basically this is the same formula. We just change for the percent, which is 10% for the T1, 90% for the T2. T3 is 50%. So for the V peak in this simulation, we got the 99.564 kilovolt. And T1, we got the answer is 9.956 kilovolts. For the time is 547.758 nanosecond, and for the T2 we got the answer is 89.608 kilovolt. For the time is 1.21062 microsecond. For the T3, 49.782 kilovolt. For the time is 6.8549. And then we need to find the TF and the TT. For the TF formula, TF equal to 1.25 times T2 minus T1. We got the answer is in the times 0.836 microsecond. For the TT, TT equal to T3 minus T0, which is T0 equal to 0. So the same answer to the T3. For the simulation, we need to find out the reading from the calculation, which is this is T1, T2, and then V peaks, and T3 equal to TT. For the TF, this one is near to VP and T2. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aminul Shazwan bin Muhammad Syurizal. Okay, I will continue with my presentation, which is the discussion. Okay, first, EMK generator figure a single stage design with condenser rated at 0.16 farad and a charging voltage of 125 kilovolt, enhancing its operational capabilities. Then the equation of 1000 picofarad load capacitor highlights its role in transmitting impulse to external device under test. The critical calculation for series resistance and damping resistance are necessary to generate a precise 1.2 and 50 microsecond impulse wave, influencing waveform shape and duration. The determination of maximum output voltage considering a charging voltage of 120 kV provide insight into peak performance and potential stress on tested equipment. And lastly, the simulation of the impulse generator using ORCAD software, the validation allowing to evaluation of waveform and measurement like T1, T2 and T3 for design refinement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Bismail. So for the last part, I will explain about the conclusion. So in conclusion, this report outlines the successful design and simulation of an impulse generator featuring a single stage with each condenser rated at 0.16 microfarad and 125 kV. The meticulous determination of key parameters such as a series resistance, damping resistance and maximum output voltage ensure the generation of a precise 1.2 over 50 microsecond impulse wave. Careful consideration of resistor values play a pivotal role in achieving the desired waveform characteristic, controlling rise and fall times. The analysis of the maximum output voltage revealed the generator's capability to reach 120 kV during the charging phase, providing crucial insights into its performance. The ORCAD simulation offers a visual representation confirming the circuit functionality and enhancing understanding. Overall, this comprehensive analysis and successful implementation underscore the impulse generator reliability and control functionality, positioning it as a valuable tool for various applications. That's it for us. Thank you.